A functional group is defined as an atom or group of atoms that give some characteristic properties to an organic compound. So, in the carbon chain, if one or more hydrogen atoms are replaced by heteroatoms such as halogens, oxygen, nitrogen, and sulfur, that group is called the functional group. Let us see them one by one. Let us start with the simplest organic compound, and that is methane, and let us see how the hydrogen atoms are replaced. Suppose in this compound, this hydrogen atom is replaced by, let us say, a halogen, and halogen is chlorine, bromine, iodine, fluorine. So if a compound is formed like this, where the hydrogen is replaced by an halogen, this is methane. Then this compound, this will be called chloromethane. So here halogen is the functional group. So this is your functional group that will decide the properties of the compound irrespective of the length of the carbon chain. All haloalkanes, as we call it as. This is chloromethane, but in general you will call this functional group as haloalkane. So all haloalkanes will show similar chemical properties irrespective of the length of the carbon atom. So this means further we can extend this as if in ethane, let us say, one hydrogen atom is replaced by chlorine atom. In that case it will be chloroethane. Similarly you can have bromoethane, iodoethane, or fluoroethane, etc. So for all, means for the linear structures, for the branches, for the rings, halogen atom can replace hydrogen and form such compound. So this functional group is called halogen. So we can define this first functional group as halogen. And when this halogen is the functional group, the name is in the name a suffix is added, halo, like this. So this halo can be chloro if heteroatom is chlorine, it can be bromo, it can be iodo, or it can be fluoro, depending on the heteroatom. So a suffix is added to the name of alkane, alkenes, alkyne, whatever it is. So the first functional group is halogen functional group. The second functional group, if we see, is alcohol. In an alcohol, similar to the first example, hydrogen is replaced by another radical, and in this case the radical is hydroxide radical, so it is OH. So if this is methane, this is called methanol. In this, what is done? See, the E in the name of the alkane is removed and its place is taken by a suffix OL. So this is a suffix OL. So we have methanol. Similarly, we can have ethanol. That will be CH3 CH2 OH. So this will be ethanol. Now, while naming these compounds with the functional groups, sometimes number is also important. How? That we will see. Suppose we have two compounds having, let us say, 3 carbon atom. So the first compound is like this. By looking at the functional group, you know it is alcohol because of this OH radical you see here. Then you will name this compound as propanol. but there can be a there can be an isomer to this. And what will be that? In the carbon chain, if the hydroxide radical is attached to the middle carbon, then the structure of the compound will be different, even though the chemical formula will remain same. So how to name this? Here we number the carbon chain as 1, 2, 3 and say the functional group is attached to second carbon atom. And here 1, 2, 3. We can name from right to left or left to right. That doesn't make any difference. So here the functional group is attached to the first carbon, whereas here functional group is attached to second carbon. So we name this compound as propane 1-ol and this compound as propane 2-ol. Look at this. So here the functional group is attached to the first carbon, so that's why number 1 here, and here the functional group is attached to second carbon, so that's why it is propane 2-ol here. Similarly, there can be a halogen functional group also, likewise. That means in a 3 carbon chain, let us say bromine can be attached to the middle carbon as well. So in that case, how will you name it? You will name it as 2-bromopropane, 2-bromopropane, because the functional group is attached to the second carbon in this case. So that can be different like this. In case of halogen, one more thing can occur. That means there can be multiple halo group attached, like here a chlorine is attached, let us say, then another chlorine is attached here, so there can be 2 chlorine like this. So in that case, again we will number the carbon atoms and name it accordingly. So 1 and 2. So we will write it as 1, 2 dichloro, and number of carbon atoms in main carbon chain 2. So ethane. So we will name this compound as 1, 2 dichloroethane. So in halogen functional group, there can be multiple halogen atoms and we have to write. This can also happen that the halogen is attached to the same carbon like this. In that case, name will be different and name will be 1, 1 dichloroethane. Here 1, 1 dichloroethane. So like this, even hydroxide group can be bonded with multiple carbon atom, and then the alcohols are called diols and triols and all that, but this is not covered in our syllabus as yet, so let us skip that. The third functional group is called aldehyde. So halogen functional group and after that alcohol. Third functional group is aldehyde. In aldehyde functional group, there is a carbon oxygen double bond attached to the end carbon atom. So this is your simplest aldehyde. Now see, here no hydrogen will be attached because oxygen is forming a double bond with this carbon. So 2 valencies of carbon fulfilled here, third one here, fourth one here. This compound is called methanol. Methanol. Again, E from the name methane is removed and the suffix Al is added. Similarly, you can have ethanol with 2 carbon atoms. So the functional group here, as you can see, it is CHO. CHO. To the end means to the first carbon or the last carbon. It cannot be attached to any middle carbon atom. At the end it should be there. So it can be for 3 carbon atom, that is propanol, the structure will be like this. You can also write it as HCHO, methanol. You can write this as CH3CHO, and then it is ethanol, and then here you can write CH3CH2CHO, and that is nothing but propanol. If the carbon oxygen double bond occurs in the middle of carbon chain, then the functional group is ketone. And as the carbon oxygen double bond has to be there in the middle of the chain, there should at least be 3 carbon atom, correct? Otherwise it will be attached to the end carbon atom and will be called aldehyde. So for a ketone, carbon oxygen double bond is present in the middle of the chain. So here we name this as propanone. Propanone. Again the suffix is ONE, propanone. Then we can have butanone like this, double bond O like this. This will be called butanone. So this is a ketone functional group in which carbon oxygen double bond is present in the middle of the chain. Then the last functional group that we are going to learn is carboxylic acid. Carboxylic acid. In carboxylic acid, and simplest carboxylic acid is like this. It is slightly different than aldehyde. In aldehyde there is carbon hydrogen single bond here. Here it is carbon hydroxide single bond. And the name of the compound here is methanoic acid. So your suffix is OIC acid. So this is methanoic acid, and then you have ethanoic acid. So functional group is COOH. So this is your ethanoic acid, and so on and so forth. So these are the 5 functional group, namely halogens. First of all, we have seen the halogen functional group, then alcohols, aldehydes, ketones, and finally carboxylic acid. Then we have something called homologous series. What is a homologous series? Consider alkanes like this. So first alkane is like this, then you have next alkane like this. The alkane with 3 carbon atoms is like this, and so on and so forth. We are writing the linear chain compound. So this is CH4, isn't it? This is CH3 single bond CH3. This is CH3 CH2 CH3, and similarly we can have butane, which can be written as CH3 CH2 CH2 CH3. Here you can see one CH2 is added, means if you write it as CH4, and here in that if one CH2 is added, it gives you C2H6, and if you look at this formula, it is actually C2H6. So one CH2 is added here. Again here it is clearly seen that one more CH2 is added. Again you can see that one more CH2 is added. So each next member is having a additional CH2 group. So such series of compounds we call it as homologous series. It's a group of carbon compound having same general formula and same functional group. So this is a homologous series of alkanes, you can see. and general formula is CnH2n plus 2, like this. Similarly, we can have a homologous series of alkenes, like the simplest one is CH2 double bond CH2, then we have CH3CH double bond CH2, then we have CH3CH2CH double bond CH2, and so on and so forth. Here also you can see that every time one CH2 group is added. So this is a homologous series of alkenes, and with a general formula CnH2n. Similarly, we can have a homologous series of alkynes in which CH triple bond CH is there. Then we have CH, C and triple bond CH, like this. So if it is C2H2, and here you can say that it is C3H4. So in this, if CH2 is added, it is C3H4. So this is the one. Then you can have CH3 CH2C and triple bond CH. So this is an homologous series of alkynes with general formula CnH2n minus 2. Then we can have a, let us say, homologous series of haloalkanes with general formula RCl, and compounds like CH3Cl, CH3CH2Cl, CH3CH2, CH2Cl, and so on and so forth. Alcohols ROH, like CH3OH, then we have CH3CH2OH, then we have CH3CH2CH2OH, and so on and so forth. So we can have the homologous series. Now the properties of homologous series are as follows. Each member of homologous series differs by a CH2 group. So if you see the molecular mass, each new member adds a 14U of molecular mass. Then the chemical properties of all the compounds in a homologous series are similar, whereas the physical property show the gradation, like smaller will be the gases, then after that some heavier members will be liquid, and still heavier members will be solid.